We're going live, and we're live now. And welcome back to the OpenShift Origin Community Hangout. This week we are really happy to have as our topic getting started on with ElasticSearch on OpenShift, and two great community members, Kurt Hurtado, I think that's how you say it, Hurtado from ElasticSearch. I think you're based down in California, and Mateus Caruccio, who is based in Porto Alegre, Brazil. So that's quite a big of a distance, and so we really appreciate you coming in and logging in today. We're going to start off, we're going to get Kurt to give us a little bit of an introduction to ElasticSearch for those of you who haven't heard of it before, and I'm going to let you do that. And Kurt, why don't you introduce yourself, and we can then share your desktop and walk through those wonderful slides you have.
Sure. My name is Kurt Hurtado, and I've been with ElasticSearch for about 9 months now. Have a career based in both software engineering as well as operations. So if you know the DevOps term, that's something that might be describing my skill set. So I like to approach things from both software as well as an operational point of view. So I'm going to jump right in and give people sort of the 10,000-foot view of not just Elasticsearch, but the full ELK stack, which includes Elasticsearch, Logstash, and Kibana. And with any amount of luck, I should be able to do that. Let's see. All right. So, the ELK stack in a nutshell. ELK was first conceived of as a separate project. So, Logstash was started around 2009 by Jordan Sissel. Elasticsearch, the first version, was released in 2010 by Shai Bannon. Then Kibana, around 2011, was first released by Rashid Khan. Elasticsearch, the actual company, was founded in Amsterdam in 2012, and soon to be in other countries as well, including the United States. Rashid and Kibana joined in January 2013, and Jordan joined the team in August of 2013. So now a lot of the development is done in the open source community as well as in-house, and that allows us to have a lot of interdepartmental cooperation on the various aspects of the stack to make sure that they all work well together. So let's start off with a little bit about Elasticsearch. What is Elasticsearch? It's a document-oriented search engine where all of the documents as well as the interactions with Elasticsearch are done through a JSON. So all the documents are stored in the data store as JSON and accessed as well. It's built on top of Apache Lucene, which is an open source search engine, and built to be schema-free, or you might call it schema-less, which means that you don't need to define the data types as you are indexing them, but Elasticsearch gives you lots of control over whether or not you actually do want to index in a particular manner. It's distributed, so it will scale up and out and give you high availability features. When you bring up a new node in Elasticsearch, it will automatically join a cluster, and it will relieve some of the pressure from the other nodes by distributing the shards of data to the new nodes as they come up. It's multi-tenant, so the data can live on any one of these shards and can be reallocated as Elasticsearch sees fit in order to get the best and most efficient performance out of your cluster. And it's API-centric and RESTful, so almost everything that you can do through Elasticsearch, you can do through the API. And it's a REST API using JSON, and it gives you a lot of flexibility into not only the control of the documents that you're storing in Elasticsearch, but also a lot of statistics, such as the cluster health and various metrics about how the cluster itself is doing apart from the data. So, as a quick example of this API, here is a couple of examples of the API call which you would make to create an index. So in the first one, what we're doing is we're telling Elasticsearch to create an index named A, not very descriptive, I know, and we're telling Elasticsearch to create it with 2 shards and 1 replica. So that would be a total of 4 shards, and you can see the curl on the right at the top. And then the second example is similar, but in this case we're asking Elasticsearch to create an index called B with 3 shards and 1 replica. So that would be a total of 6 shards. Now Elasticsearch would automatically allocate each of these shards of data to the number of nodes in your cluster. In the example that I have here, we have 4 nodes, and in this case Elasticsearch has put, for example, the primary for index A, shard 0 on node 1 in the top left, and it has allocated the replica to node 4 in the bottom right. So you'll see that no 2 copies of the same data will be stored on any one node, and this gives you high availability in that you can lose any one node and you will still have all the copies of your data available. This is just a sample of the way it might be allocated. There's really no way to tell. Elasticsearch has its built-in algorithms in order to determine how to allocate, but this would be some sort of a sample. Another example of the API is what we would use to index a document. So in this case, we are using the HTTP put method, and we're going to index it into an index called Crunchbase, and the document type would be person, and here we're giving it a document ID of 1, and then our payload, the body of the API request, is a JSON document, of course, where we have specified that the first name is Tony and the last name is Stark. So, not surprisingly, Elasticsearch allows you to query, search your data, and there are many, many methods which will allow you to do this. You can use unstructured search, which sort of the more common search that you would think of when you go to a website and you type something in and it finds examples of your documents. So we have pure match, where it's actually searching for analyzed tokens within your data set. You can construct using booleans, and or not, must, should, and another very useful one is the histogram, which allows you to bucket your data over time, and we'll see when we get to Kibana how useful that can be. In addition to queries, there are also filters, and filters are very fast because they are cached in memory. So if you sort of have a small set of things that you know, like the number, like size, small, medium, large, colors, if you create filters, then these get cached within Elasticsearch, and subsequent queries will give you very quick performance when you're retrieving the search results. And of course, that we can filter by terms, we can filter by various types of ranges, and construct these versus with the Boolean filters as well. A new feature which was released in 1.0 is called Aggregations. Aggregations are taking facets to a much more advanced degree. Facets were a feature of pre-1.0 Elasticsearch, where it allowed you to sort of get some numerical results based on the number of times that certain terms appeared within your documents. And aggregations take that one step further by allowing you to bucket into multiple data fields. So, for example, if we wanted to see the top URLs, we could do that, but we could also drill down a little further. We can see the top URLs by country. We could go even further and see the top URLs by country, by ISP, and this allows us to create an arbitrary number of buckets in which we can analyze our data. And again, we can aggregate over many different types of data. We can aggregate over analyzed terms, various types of ranges, including date and IP range, geo-distance, histograms, and then a few different types of statistical analysis, such as mean, max, min, sum, percentiles, etc. So, let's talk a little bit about Logstash. Logstash is, at its heart, an event processing engine, and that just means when you send something such as a log line or some sort of request to Logstash, it can process it in various ways and send it along to some other output. So it's written in Ruby, but it runs on JRuby, so it takes advantage of the Java virtual machine. So the Ruby, it's written to be very easy to extend, and then it runs very efficiently on the JVM. We have a lot of people who are just really able to contribute very quickly because of the extensible way in which it was written. Basically, the events pass through what we call the pipeline, where, first of all, the events come in through an input, where they might receive things from reading files on a file system or network events. Then they pass through filters, optionally. The filters can do various things in order to enrich the data and extract other information out of it. And finally, it's not very useful unless you hook Logstash up to an output. And an output basically is a way to pass the enriched data onto some other system. And we'll see some examples of these on the next slide. But it was designed to be very flexible, and you can take data from as many inputs as you'd like. You can run it through as many filters as you'd like, and then output it to multiple other systems simultaneously. And of course, it's most commonly used with the output. So the most common ones are going to be reading events from the network over TCP or UDP, tailing a file on a client machine, receiving our syslog messages over the network, or possibly even reading from standard in. You can also read from various types of queues, such as RabbitMQ, Redis, or Kafka, etc. And then there's some more interesting ones where you can actually pull data off of Twitter. You can read IMAP emails, pull from Amazon S3, Gelf if you're using Graylog, etc., etc. Some useful filters are Grok, which is sort of a pattern matching engine, which allows you to grab data within a log line. The date filter allows you to sort of make a canonical representation of when this event actually happened and not when it passed through the pipeline. You can mutate and run an arbitrary Ruby code over your events, which basically gives you a lot of flexibility to massage your data in various ways. A very useful one is the GeoIP filter, which allows you to extract location information from an IP address using the MaxMind database. And then on outputs, of course, the most common one is ElasticSearch, which allows you to do analysis on your data. But other people use MongoDB. You can output to files in Amazon. You can use various notification engines such as PagerDuty, Nagios, Zabbix, emails, and again, you can pass it on to more raw information such as TCP onto various queues, et cetera, et cetera. So now that you have your data stored in Elasticsearch via Logstash, we have Kibana, which is basically a data visualization tool which allows you to see visually what's going on with your data. It runs in a browser. You can serve it either locally on your laptop, for example, or remotely using some sort of a web server or a proxy. You don't need to know how to program, which is the beautiful thing about it. Anyone, you can give this to your marketing department and your executives, and they will be able to extract value from your data very quickly. We have multiple panel types, which we'll see in the next slide. You can save and share dashboards with your coworkers, and basically this just allows everyone to get access to the data, and not just those people who can log in as root and comb through log files. So here's an example of what one might look like. As we can see in the top left, the events over time, that is a histogram, so we can see sort of the patterns over the past few hours. We can see the map of where our traffic is coming from. We can break it down into various pie charts and bar charts and just express all of our data in a lot of really cool ways, which is pretty difficult when you have a lot of client machines.
So Kurt, let me just interrupt. Was that beautiful visualization, was that the open source project, or was that an enterprise version?
This is the open source version of Kibana.
Awesome.
This is actually Kibana 3, which does a lot of great stuff. But very soon we're going to be releasing Kibana 4. probably within, we'll probably see some beta versions in the next few weeks and probably released in within a month or two. But it's going to take this just to the next level. But right now, this is all fully open source and available.
Perfect.
So as I sort of touched on a little bit before, ElasticSearch has a lot of different use cases. You can use it as a free search, such as kind of when you, for example, if you go to GitHub or SoundCloud and you type in the name of a project or a song, for example, that's powered by ElasticSearch, and that allows you to just enter some search terms and get results. You can also do structured search, like I said, with filters, which allow, if you sort of know a few things, like if you're searching for houses, you know, 1 bedroom, 2 bedroom, 3 bedrooms. You can do data analytics, which Kibana helps immensely for, using histograms and just being able to see patterns in your data. Obviously, with Logstash, it's very convenient for doing log analysis. And this scales really, we have clusters running up to 50 or 100,000 events per second, which can handle a very large data center pretty easily. And of course, the visual exploration with Kibana allows you to sort of do it easily and to let everyone enjoy the fruits of your data labors. So real quick, I just want to talk about deploying the ELK Stack. The most common method, at least when you're starting up, would be manually installing it. You can download the tarballs. We have a this is all free and open source, but we do have some packages available to download as tarballs. You can also install from Linux packages and Debian and Red Hat-based systems. Or you can go directly to the GitHub repository and fork the repo and get under the hood, see what's going on there, and eventually, if you have some contributions, give back to the project. So we encourage that greatly. And then once you take it to the next level, we have some nice Puppet modules which are very actively worked on. There's a chef cookbook that we're doing a lot more recently with various container-based solutions such as CoreOS and Docker. And then, of course, now we have the ability to run some OpenShift cartridges, courtesy of Mateus. So that's all I have for today on Elasticsearch, but let Mateus take it over and explain a little bit more about that.
All right, so that's great. So next up we have Mateus Caruccio from GetUpCloud. He's the founder and CTO, or the person who does chief bottle washer too, at GetUpCloud, which is a Brazilian-based platform as a service, and they've been longtime contributors to the OpenShift Origin project, and we're really happy to have him here. And he's also recently contributed to Elasticsearch cartridges, which I'm going to get him to talk about and hopefully demonstrate successfully here for all of your viewing pleasure. So Mateus, why don't you take it away?
Thank you, Diane. Thank you, Kurt. I am Mateus. I'm CTO, CEO, and founder of GetUpCloud. Also, I make the coffee here because my coffee is better than my partner's coffee. So I've been playing with Elasticsearch for 2 months or so. And it was really easy to integrate into OpenShift on our implementation. And I have done 2 cartridges, one to run as a standalone application with all features of a normal application. You can scale, you can edit source code, or even choose the version you want to deploy. And the second one, which acts as an add-on, more like a database, where you create your application with any language you want to do, and you add that cartridge, and so your application has access to an internal Elasticsearch only for your access. The first version, it's a normal app application, so everybody has access to your URL. That's not a problem because you can configure plugins to do authentication into your URL. And I try to share my screen. Let me see.
While you're doing that, I'm just going to let people know that if you're looking for Mateus's cartridges, you can find them in origin.ly, the OpenShift Origin Index. They should be more popular recent ones on the origin.ly homepage.
Yep, I have just submitted that cartridge to origin.ly.
All right.
And they point to our GitHub repositories with the source code, so everyone can go there, fork and change or contribute. May I make a quick demonstration on how to create one application?
Please
do
so.
Easy.
So
just a single command.
Can you show your desktop now?
Yep. Let me start screen share here. Can you see my desktop?
I can see your image. Whoops. For a second. There you go.
This is the orange index. Here they are, the two most recently added. And here is the GitHub repository for the app version. There are some instructions in the README where you can follow to create your own application. However, these cartridges are not downloadable, so this command is not valid. I will fix that today. And these are cartridges meant to be installed in your own OpenShift deployment. Because we are providing our users with both cartridges, and we need to tweak with some configuration, so that change on the configurations don't allow this cartridge to be downloadable. But it is easy to turn it into a downloadable cartridge. So we can see here. I'm using GetUpCloud's OpenShift implementation because the cartridges are already installed there. I have two cartridges. I will demonstrate only one because it can. So we create a new app. I say app create. I will call it yes app and the name of the cartridge. Want it to be scalable. This command is everything you need to create your ElasticSearch instance. It creates a application named yes app under my domain. So the URL will be yesapp-caruccio.getup.io. It can take some time because the cartridge downloads the ElasticSearch binary from ElasticSearch servers. The cartridge itself is only a few scripts and some metadata files. Okay, DNS available. Now the RHC command just cloned my remote repository for the application. If I go there, you can see there is this is the GitHub repository of the application, not the cartridge. So I can, if I want to add some plugins, there are many examples. So let's install one I think is very useful, which is, oops, add just one comment here. I'm installing from GitHub. This is the developer account, and this is the repository name on GitHub. Save here, git commit. Oops. This push will update the remote application repository, stopping the ElasticSearch process, install the plugins from plugins.txt, and restart ElasticSearch. Okay, done. Now we can go to app. Well, this is the root endpoint, but I install it so we can use it now. Okay, our cluster has only one node, and we can scale out with a simple command. Name of the category. Let's add a new gear. The app name here. The category take care to set up the communication between every gear. If you are running on your own network or Amazon or wherever, this is automatic. But here in OpenShift, we need to explicitly give the ElasticSearch instances where are the other instances, or where is the master instance, master node, so it can build up the network of nodes. That was the biggest challenge on building this cartridge. Yet not a huge challenge, but did some work. In fact, I had some a huge help from a fellow from Red Hat and Goldstein.
Yep.
Yeah. He did the initial development, and I helped him finishing. And after that, I built the add-on version. Well, here it is scaled. I can refresh here, and another node is added. Well, I guess there's no need to show you the add-on version. It's pretty straightforward. It's just like adding a MySQL database, and it can scale too, but it's a little bit harder because you need to install any plugins inside each gear. If you need to install a plugin on each node of ElasticSearch, you need to SSH into it gear and install it there. The scaling is also a little bit different, but the README file explains step by step how to do that.
Well, that's great. I think it's a wonderful, good place to start from to start playing with ElasticSearch. I know people are using Logstash on OpenShift as well.
Mm-hmm.
I haven't yet seen anybody using Kibana, so I think that the interesting thing will be to try and get to the next stage and get a quick start that has all the ELK stack involved with a sample application. That would be
sure.
That would be a great thing to move forward and to get some basic intro content available for people to really work through a good sample application. I know on the ElasticSearch site there are quite a few sample applications and things for people to play with. So I think we're probably a few months away from having a full-blown decent sample app, but the cartridges that Mateus has built has really gotten us moving a lot further along. I'm really grateful for that work. I think it was Andy Goldstein that kicked off some of the work on Elasticsearch, and the number of customers have been customers and users have asked us about it. So I'm really pleased that we've gotten this far with the community support. I know there's another company out there that I've been talking to, Found.no, I think is their name, that does also also does Elasticsearch as a service. And we're going to try and get them on in the next week or so to give a demonstration of hooking up an application using their service. So there's lots of options for working with Elasticsearch. We hope we have enlightened you a little bit. Mateus, what would you see as the next step for someone using your Elasticsearch cartridge?
I strongly recommend everyone to read the documentation from the site. It's really comprehensive and easy to read, and there are many examples. I myself, I don't use Elasticsearch yet. We are planning to use here the full stack for our log analysis. But the documentation from elasticsearch.com or org, I never know.
It's org.
Org. Okay. I have autocomplete here. I don't care anymore.
I sometimes go.
I don't trust my memory anymore. So the documentation is pretty good.
This is a good way. It's a good first step. There's also what I'm looking forward to is getting Elasticsearch into the OpenShift marketplace and a supported version of these cartridges. So we have someone who's maintaining them and working on them over time, and so that's what we'll probably be working with the folks from Elasticsearch to make that happen and get them so that the Enterprise Online and folks can have it as well. But I think as with pretty much everything in OpenShift, it all starts at the origin community level, and this is where we test out and break things and make things work better with the cartridges. So if anyone who's listening to this wants to check it out, it is both of these cartridges are in origin.ly and you can get to that from the origin.openshift.com page, or you can just search for it in GitHub and you'll find it in GetUpCloud repo. So hopefully,
and I think that as Mateus, or you were saying about having all three, the Elasticsearch, Logstash, and Kibana packaged in one. That's a request that we get all the time, and I think that would be really valuable to have something where someone could bring all that up and just start to play around. When you get to a little bit further, larger deployments, then you kind of need to break it up and have dedicated servers for each of the elements of the stack. But I think to have something where someone could download really quickly and bring up the full stack would be immensely valuable. So this is good work. Good work on what you got so far.
Thank you. Thank you. That's my plan. I'm planning to deploy a Kibana instance and then Logstash, but I'm not sure if I'm going to do that as separated applications, or I could put it up in a single application. I'm trying yet, but no good conclusions so far.
So what I'm looking for are other folks to help work on this and make it a reality a little quicker, and hopefully we can get that going. I've got a couple of friends with some very large repositories of XML documents that I'm trying to coerce into converting into an Elasticsearch database so that we can parse that. And I think this has got some really good applications in the open data world as well. So hopefully we can pull a few more community members and get some folks from Elasticsearch with some eyeballs on this, and we'll get it going pretty quick here. So once again, thank you all for joining us today, and if you have any questions at all, you can find Kurt at elasticsearch.org or elasticsearch.com, I think works as well. Org is always good. I'm working on .org for OpenShift going. And you can find Mateus at GetUpCloud.com. And often you can find all of us on OpenShift's Freenode IRC channel, OpenShift-dev. That's a really great place to look for us and ask questions. So We look forward to hearing more from you, and if you want to work on this with us, reach out and you can get a hold of us really easily on the origin.openshift.com site. So thanks, everybody, and we'll talk to you all again very shortly.
Thank you. It was a pleasure.
Thank you. Thanks for having us.